So it's the 15th. I'm not going to hand out the assignment today, but we will try to get through. If we can get through 2 examples out of 4, I'll consider that a huge win. All right. So our first problem is, so we are doing more radical equations. Okay. Just for the record, though, the way these are going to look, so you can like head it in your notes if you want to, is we're going to have a radical and then an equal sign and then another radical, which we learned yesterday, by the way, right? But as I tried to warn you, there's going to be a bonus number lingering, loitering someplace. And whether it's on the left side or the right side, or if it's a +5 or a -2 or a whatever, that's irrelevant. It doesn't really change how annoying these are. But that extra number makes everything worse because when you square both sides, if this number is not here, as you learned yesterday, it's easy. It's a joke, right? But as soon as you put that extra number back in there, then the square square multiply double process, or the however you want to say it on the side with the number, it's a thing, right? It's nothing you can't handle. It's just a thing. It's a bigger thing. So here's our first example. Let's do the square root of 2x plus 3 equals 3 plus the square root of 3x minus 9. You will, over time, this is not the right time to discuss it in detail, but over the next couple days, you'll start to develop preferences as to where you want the things to go. But the idea of let's quote unquote get the radical by itself, it no longer has any significance, right? Because if I get the radical on the left by itself, then the 3 loiters on the right. But if I move the 3 to the left and I get the other radical by itself, the 3 is not going to go away, right? Having that awkward third wheel, so to speak, is going to be, um, it is what it is. Like there's really, bless you, there's really no great workaround to this. So anyhow, what we're going to do is we're going to square both sides. And again, normally we wait until we get the radical by itself, but like I said, that's not really going to happen here, right? There's 2 radicals, and it's like, what do you want me to do? So if we square the left side, that's easy. That's super light work, right? Having done this for a few days, we have no issues with the fact that when you square just a simple radical, a square root more specifically, that you just get what was inside. 80 or 90% of our stress and our conversations and your questions are going to come from what we're about to do, and that's squaring the right-hand side. And the thing about squaring the right-hand side is that it's a square square multiply double problem, and it's super dangerous. So for this first go, we're going to write it out. And I would say that only some of you will start to shortcut with square square multiply double. And I would say the vast majority of you will or should probably just continue to do it the way I'm about to do it, that we're about to do it. Okay. So when we square the yellow math problem, I'm going to kind of wiggle over and give myself a little room here. So this is what it's going to look like. It's going to be 3 plus the root of 3x minus 9 times 3 plus the root of 3x minus 9. Kind of seems weird to give you the moral of the story before I tell you the story, but the moral of the upcoming story is that you cannot kill both radicals in one step. As you'll see, there's going to be residual root. There's not really much you can do about it. So when we square the right side, it looks like this, what I have written up there on the board. And we're just going to go through and do this algebra 1 way. We're going to foil this old school just to make sure that we see what's happening. So if we go through the first, outer, inner, last process, no issues here. What's 3 times 3? 9. Okay, and this is where it gets a little bit stressful, perhaps. The purple math problem comes next. Whenever we do first foil, first, outer, inner, last, whenever we multiply things like this, uh, at some point the purple has to happen, right? What do you get? Be careful. Hint, it's not a math problem. What do you get? Yes, like I said, good job. Good cue, good taking of the cue there. You don't math this, you don't distribute this. When you multiply 3 by the root of 3x minus 9, you get quite literally 3 roots of 3x minus 9. Like I'm not holding out on you there. It's not like that's the Mr. Ahern way to do it. It's just what it is, right? And then we're going to head to the I, the inner. We're going to multiply the green combo next, of course. And what's that going to give us? The same thing, right? Only I'm going to write it in green because that's how I roll. So it's going to be, again, another 3 roots of 3x minus 9. And then the final pairing is yellow, and that's the L in FOIL, last term times last term. And what does that give me? The thing about this is that those roots are identical to each other. So under normal circumstances, let me just again go this way, just so I don't want you looking at this for a second. If I gave you a square root of 3 times the square root of 5, I need you to know that that's the square root of 15, right? It is what it is. However, if we're fortunate enough to have two square roots that are the same, we can bypass the middle step, right? What is the root 5 times the root 5? It is just 5. We can bypass the middle step because the middle step would have just said, like if I put a middle step in here, it would be root of 25, which, and then we just shoot down and get 5. The moral there is that if you multiply two identical roots, it's like you knew this, that you just get what's inside, right? So having said that, you would agree, if I go back now, that we are in fact multiplying two identical roots, correct? So what do we get? Correct. And there, if it doesn't happen today, maybe it'll happen tomorrow. There comes a point where you will just start square, square, multiply, doubling these quickly and in your head. But only do it if you're comfortable and if you're ready. And if you never are, then just don't. Do it this way every time. You'll notice, as always is the case when we FOIL things, that the two terms in the middle are like terms, right? So we're going to put those together. So we're going to wind up with, um, let's see, I'm going to put those together first, I guess. We don't have to. I will. I'm going to do 6 roots of 3x minus 9. And what else do I have? I hope I didn't lose anybody. Do we all agree if you got 3 somethings and you add 3 more, you got 6 of the same somethings, right? The somethings don't change, just the number of them that we have. And then what else do I have? Yeah, and tell me about this 9 and this negative 9. They're just going to go away, right? So I don't even need to acknowledge their existence. Don't think that that's always going to happen. It just, and this problem did, right? It's not a thing. And then there is an extra plus 3x. You can see that's not your run-of-the-mill square, square, multiply, double problem, right? Eventually it will be. Days from now, you'll look back and think, oh, I can't believe I ever was struggling with that. Nothing. So now we need to take that and move it. Well, I can move it. You can't really do this with a pencil, but I'm going to take that now. And oh, I got lucky. I stuck it right next to the equal sign. And this is what our problem should now look like. Got it? But I said this 5 minutes ago, you cannot kill both roots in one move because of what you just saw. That extra term, he's a booger. That 3 at the beginning is a booger. And so we are now in a position where we essentially have to regather our parts and pieces and go again. Okay, we have to hit it with another treatment of kill the radical ointment. So having said that, we are going to isolate now this yellow thing, this blob, because I need to get this in a position now where if I square it again, when I hit it with dose number 2, that I can kill the radical now effectively. And you're in a position now to make this happen because there's only one radical left. So the way I feel about this is knowing, and I can see maybe the writing on the wall a little more clearly than you. I don't really care where I put the yellow egg. What I'm interested in is these 2 purple boxes. And I always want to control my equation to make my life easier. And it's always going to be easier if you keep that one positive. Just a little bit easier, okay? So what I'm going to do in this case is I'm going to take the 2x and I'm going to move it over to the right side, giving me 1x. I am then going to take the 3, move it over, making -3. And then I'm going to set it equal to the negative of the 6 roots of 3x minus 9. And again, I'm positioning things in a strategic manner, and I'm going to put one thing on the board right now in red, and it's this. I want that to be positive, the red thing. Everything else follows, goes, but he's like the master term, right? Are you with me? And now essentially you take a deep breath and realize that after all of that, the problem now begins again, and we have to go round 2. Got it? So let's square both sides again. And this time it's like that second go round with the wasp spray at the nest up there. Like this time I'm getting them all. I'm going to finish the job. So when I square the left and I square the right, I'll be done with the radicals. Never asked you this question before, so I'll throw it out. I won't make fun of you if you don't know. What is the left side going to equal? Good try, but nope. The left side will equal 36 times the quantity of 3x minus 9. There are 2 parts, and they both get squared by that green exponent. So the exponent says I shall square that guy, and I shall also square that guy. Okay. And then the right side, the fun never ends. Every time we think we're in the clear, it just keeps coming. So how about the right side? Square, square, multiply, double. Go for it. Yes. You did that very successfully. Hey, some good news. Look what we did. We did a thing. The radicals are now gone. And mind you, we've been in this problem for 10 minutes, and now we have the great honor and joy of solving the equation, the quadratic equation.
Excellent.
Nice. That joke was radical. Don't Come on. Don't be so sad. Imagine a world without awesome jokes. What you're saying right now. See, I'm living in it. Thanks. So we're going to solve now. And of course, this is more of like a way earlier in the year kind of problem now. If you distribute the 36, you get 108 x's minus 324 equals x squared minus 6x plus 9. This is normally the part of the problem, as you know from your past couple days, where you kind of go, whew, I made it. And then you look at this beast and you kind of go, what is this garbage? Okay, yeah. So like I said, these problems just keep punching and punching and punching. And so this quadratic equation, of course, we're going to let the decisions be dominated by x squared. He's like, I'm not going anywhere. So x squared is going to stay here. How many x's are we going to have right next to him? Nope. Negative 114 x's. And what's the number going to be at the end? The constant, the c? Ah! Plus, were you about to subtract 324 from both sides? Plus 333 equals 0. And that's a little bit frightening, huh? It's a little bit of a intimidating prospect here. Hey, but we made it. We're almost there now. And does anyone happen to know anything really cool about a couple numbers that would multiply to make 333 that might just make something really cool happen in this quadratic? I would never ask this of my Algebra 1 students, but you guys aren't Algebra 1. You can do it. Hey, look, Mrs. Wiles, do you see it's happening in both classes? We're factoring. How fun. How excited she is. Well, here, I'll get you started. So here we got shells, we got X. What are my signs going to be? A minus and a minus, did you say? Good. Yeah, we need 2 minuses. Anyone see any cool numbers that multiply to make 333 that do another really cool thing?
111.
Oh. Yeah, look at that. So while it may be a frightening looking factoring problem, the math gods sort of bestow upon you a vision, right? And then you say, ah, but God Almighty, yeah, he's out of control, right? I borrow some duct tape. So my answers are x equals 111 and x equals 3. Was this the most fun you've had all day? Hey, we're not even done. This is only one problem, and we're still not done. Why aren't we done? Because we got to check them. Uh, so I'm going to head up to the top where the beginning problem was, and I'm going to erase some of my colorful vandalism, and I'm going to just use this as a workspace up here. And then I'm going to erase a whole bunch of my work. And then we're going to check our answers. So our answers, remember, we said x maybe equals 111 and x maybe equals 3. So those are both, I don't know. So help me out with 111. Okay, we shouldn't need calculators for this, just for the record, but it's okay if you use them. If we put 111 where the red arrows are pointing, let's start with just one, the first red arrow. What's 2 times 111? And what's 222 plus 3? And what's the square root of 225? 15. And then on the right-hand side, we're going to go to, I'll switch colors. Let's go to where the green arrow is. What's 3 times 111? And what's 333 minus 9? 324. And what's the square root of 324? It is 18. And what is 3 plus 18? 21. So 111 is trying to produce the result. It's trying to tell us a big fat lie that 15 on the left side is the same as 21 on the right side, which of course is not true. So x equals 111 gets a red X of shape. Got it? Now let's test 3. If we go to where the red arrow is pointing first, what is this is easy math. What's 2 times 3? 6 plus 3, square root of 9. 3, go to the right side, green arrow. What's 3 times 3? What's 9 minus 9? Square root of 0. 3 plus 0 is 3 equals 3. This one can have the green check mark of awesomeness, meaning that when I check my work, 111 got crossed, 3 gets boxed. In my defense, I have been trying to warn you for a couple of days that these are not just a little bit of a jump. Like, it's a big deal. And what's interesting about it is all of this headache, all of this fun that you just got to have was the result of one little thing. And it's this. You add one extra number and this happens. Fun, huh? Let's do this so that we're ready for tomorrow. Okay, let's make good use of our time. And then after we do this, we'll pack up and be done for today. Or maybe we'll start the first step. I don't know, but you're probably already mad at me enough. So maybe I don't want to press my luck. Problem 2 is going to say this. So example number 2. And just think, I have 4 of these. Man, you guys are lucky. Who's luckier than you guys? Think of all the kids that are sitting in boring classes, not you guys. How about this? We'll go with a, a handful of lifesavers, if anyone can mentally here. The right side doesn't count. I got the right side there. Oof, wipe sweat from brow. It's the left side. Can anyone mentally, no work shown. You can't show your work. Square, square, multiply, double the left side. Go. I knew you were going to go for it. I knew it was going to be you. Go.
9.
Yes. We're holding up.
Is it when you combine them?
I'm not the one earning the lifesavers here, Parker. You are.
Yes. So
Am I in?
minus
No, you're out. Anybody else? We will, let's do this. Let's remind me, and by let's, I mean you guys, remind me that we're going to start tomorrow's lecture right there. Okay, we're going to be in example 2, and we were just about to square, square, multiply, double the left side. And we're not ready for that yet. I just thought I'd throw out and offer people candy and great things happen. But you know, we're nothing's stopping us from just writing it out. -3 minus Rudy toot times another -3 minus Rudy toot, and you just foil that sucker out. I just thought maybe.
I distracted.
Sure, likely story.